Maybe they
Okay,
can.
we are all set up. And we've got 9 attendees, but you know what? I'm going to wait a little longer because this is a full program. Like all 75 spaces were booked for this program when I last checked. So I'm going to let everybody log on for a little bit more. Maybe just another minute or two before we introduce our guest, our very special guest. And I'm sorry I'm wearing a mask, everybody. When we planned this, we didn't think we'd have to wear masks at work, but now we are, just in case. I've got my friend Brooke here beside me. She's wearing a mask too, so we're being very careful with each other. Okay. Well, I will then introduce Dr. Cassandra Marion, who is here with us, science advisor at the Canada Aviation and Space Museum, and she is going to give us a tour of the solar system, or at least as much of it as we can cover in half an hour or so. So without any further ado, please help me welcome Dr. Cassandra Marion. Welcome, welcome, welcome. And while you're logging on, type into the chat where you're logging on from. We'd love to know where everybody's coming from. And you can also type any questions in the chat or the Q&A, and I will collect those and ask them during question time. So take it away, Dr. Marion.
Thanks, Brandon, and hi, everyone. So as you mentioned, my name is Cass, and I'm coming to you from the Canada Aviation and Space Museum in Ottawa. And I'm going to take you on a tour of the solar system, but through the eyes of spacecraft. So most of the vast majority of the images I'm going to show you today are real images of our solar system, planets, moons, asteroids in our solar system. And when I say spacecraft, I'm just talking about, a machine or a robot that we send into space to be our eyes and ears, to go out there and explore where we can't yet go. So I'm going to start off by saying, what is a solar system? Well, the solar system just means that there's a star in the center, and everything that is linked to it by gravity, which includes planets, moons, asteroids, comets, are part of that solar system, that star's system. There are many, many solar systems in our Milky Way Galaxy, and we are but one of probably millions, and just a tiny speck in the vast universe where we live. So this is what our solar system, our home solar system, looks like. So from the far left, you've got the sun, which is massive. It's bigger than anything else in our solar system. Jupiter is our largest planet, and the sun is 1,000 times the size of Jupiter. It's huge. And then closest to the sun, orbiting to the sun, we call the rocky planets. So there are 4 rocky planets: Mercury, Venus, Earth, and Mars. So we are the third rock from the sun. Between the orbits of Mars and Jupiter, there's the asteroid belt. So basically a bunch of sort of space rocks orbiting there, but they're much smaller than the planets. Then we have the gas giants: Jupiter, Saturn, Uranus, and Neptune. And we call that the outer solar system, the region of the gas giants. And though when you're looking at this image, these planets, their sizes are to scale. So Jupiter is that much bigger than Mars. The distances between them are not. And the other thing that's missing from this image is all of the other smaller bodies in the solar system, like asteroids. We actually have 5 dwarf planets too, which includes Pluto, which would be out beyond Neptune. So we'll show you that in just a bit too. But if we were to look at how far apart these planets actually are, it looks something more like this. So you've got the sun here, the rocky inner planets, they're pretty close together, but the outer planets, the outer solar system planets, are crazy far. Neptune is 4.5 billion kilometers from the sun. It's way out there, and that isn't even the end of our solar system. Beyond Neptune, there's a huge cloud of icy, rocky bits of space rocks and space ice that are orbiting the sun, and then a huge cloud that covers all of it, and it just keeps on going. So our solar system is huge, but we have 8 pretty large planets And then they have, some of them have moons, and we're going to sort of step out from the sun out and explore those planets and some of their moons. I can't get to everything. There's a lot of wacky celestial bodies in our solar system, but I will give you some hints on where you can go exploring more for the things that I don't get to talk to you about today. That hint is this NASA EYES Solar System Explorer. This is a website that you can go to, and I'm going to ask Brandon if he can drop the link into the chat for you. You can go to this, use it in your web browser. This is sort of the web browser version, but I'm going to show you a slightly different version. And you can go and you can download the app, or you can just use it on your browser. And you can go and explore the solar system yourself. And you just scroll around with your mouse. It's really easy. It looks like it's very busy and complicated, but it's not. And you see all these circles are the orbits. This is the path that planets take as they're circling around the sun. We call that their orbit. And so you can see this is Neptune's orbit here. This is Pluto's orbit. And if I zoom in more, you can see the sun is in the center, right? So just to give you an idea of the path that they take around the sun. But now what I'm going to do is back up. And the reason I really wanted to show you this as well is that you get the side view. All of these planets orbiting our sun, they actually orbit on a plane. So I'm going to move this like this, and you can see that it's on a plane. So there are orbiting on the plane, except for some of these bodies like comets and things like Pluto orbit off the plane. So they have some really funky orbits. So just to keep in mind that they're all orbiting. It looks very circular, but some of the orbits are really stretched out, more elliptical than others, and each one is a bit different. All right, so I'll go back to my presentation. Now you have an idea of the big picture before we go one by one. So I'm going to start with the sun, our star at the center of our solar system. It really is this giant ball of burning gases. And it's, like I said, it's the most massive thing in the solar system. And what's going on is a process called nuclear fusion, and it produces a lot of heat. And there's even explosions on the surface of the sun. You get solar flares, solar eruptions, lots of activity on our sun. But it's really important that our sun is hot like that because it influences all the environments on Earth and on all the other celestial bodies in the solar system. Without the sun, we would have no heat, no light, and definitely no life. And its temperature is about 5,500 degrees Celsius. So it's pretty warm. And this particular image was taken by a spacecraft that's orbiting the Earth. It's actually an observatory, a telescope that orbits the Earth called the Solar Dynamics Observatory. And so the closest rock from the sun is Mercury. It's the smallest planet, just a little bit bigger than our moon. And it's very dry, very hot. It has no atmosphere because the sun has really blown off any of the gases that might have hung around Mercury in its early formation. And if you look at the surface, you can see that it's covered with all of these round circular features. They look like little holes in the surface. Anybody have any ideas? You can put it in the chat if you'd like, of what those round things are that are covering the surface. It looks similar to some of the features that you might see on the moon. Any ideas? Yeah, you got it. They're craters. They are impact craters. These are basically holes in the ground. They're depressions that are formed from the collision of other space rocks into the surface. And early in the formation of the solar system, this happened. It still happens today, but it happened a lot more often. Really, that's, it's collisions that made our planets in the early days. And then so, every one of these little pockmarks, that is space rocks smashing into the surface of Mercury. It's actually the most common feature on all of the solid bodies in our solar system. So you're going to see this feature very often. This is the Mina crater on the planet Mercury. And I point this one out because it's very fresh. It actually happened fairly recently. And you can see that all of these stripy things coming out from the crater, that's what we call ejecta rays. This is material that was thrown out of the crater, excavated from the crater and deposited all around after the impact. And seeing these rays, that's how we know that it happened pretty recently. So let's skip on to Venus. Venus is our closest neighbor. It's really our twin in size. It's very similar to the size of Earth. and in chemistry, the insides of Earth from a rock point of view. But other than that, it's nothing like the Earth. It's extremely hot. It's hotter than Venus, 465 degrees Celsius on the surface of this planet. That's the temperature of your oven when you're, baking a casserole. I have two different images of Venus. So on the right, I'm going to start on the left. On the left is Venus as mostly what you would see with the naked eye. This is the clouds on Venus. This image was taken by the Akatsuki. It's a Japanese orbiter in orbit around Venus right now. It's actually the only thing that's still operating on Venus. And it took this beautiful image of Venus's clouds. But Venus has an incredibly thick atmosphere, very, very dense clouds. Its atmosphere is made up of carbon dioxide for the most part, and it has these sulfuric acid toxic clouds that you can't see through. And so on the right is actually a map that's made up of radio wave, where we used radio waves. So we used a technique called radar to map the surface, because radio waves can penetrate the clouds. And so this is a surface map. The colors are not real colors, but they represent sort of higher and lower topography. So the type of terrain that you have on Venus. And it's actually mostly volcanic terrain. Venus is covered in volcanoes and lava flows, but we're not sure yet if those volcanoes are still active in any way, but we're sending more missions in the next couple of years. 3 of them just got slated, so we're going to know more soon. But unfortunately, Venus is not very hospitable for humans. But one of the cool things is it's one of the very first places in the solar system that we visited. It's the very first planet that we safely landed on and took pictures from the surface on, the first planet that we recorded sounds on, and we've actually flown balloons in its clouds as well. And this is what the surface of Venus looks like. This was taken by a Venera lander spacecraft. It was a Soviet Union spacecraft. It landed a couple of different ones. Because of the heat on the surface, it didn't last very long. The longest lasting lander that they've had on Venus so far lasted only 2 hours before all of its electrical equipment melted. And so this is our view of Venus. Some of the only ones that we have. They're pretty similar. It's pretty rocky, and it landed on a lava flow. And now Earth. This is, of course, our favorite planet because it's the best place to live. And we like to call planet Earth the blue marble. And you might see that you've got the North American continent here. And so Canada is up here. This is the States, Mexico, the Caribbean. And I'm in Ottawa up here. Cambridge, where Brandon is being pointed out on here. And then this to the right is another view of Earth from the International Space Station. So this is a Soyuz capsule that's docked into the International Space Station. And this is Lake Huron, Georgia Bay, Lake Erie, Lake Ontario. Toronto is somewhere around here. And I'm up here. So Earth is really special in our solar system. It's the only planet that has liquid water on the surface. Lots of planets have tons of water, but none of it is liquid on the surface. And it's the only planet that we know of that supports life as we know it. It's also a very active planet. It's the only planet with plate tectonics. So the crust of the Earth is in, kind of puzzle pieces, and they're moving around because it's still warm in the center. We've got volcanoes erupting. We've got weather, erosion, glaciers. It's awesome. So I'm going to move on. There's tons of things that you can look up online to see images from satellites of Earth. I can do a presentation just on that, but I'm going to let you Google those for yourself and move on to the stuff a little further away from home. Here's our moon. Earth is special in that it has one very large moon. So the moon is about a quarter the size of Earth, but that comparison is fairly unique. The only other body in the solar system that has a moon similar in size to it is Pluto. And so if you look at the surface of the moon, you see there's the dark stuff and some lighter stuff. The dark stuff, those are ancient volcanic lava plains. They're ancient volcanic lava flows. And the white stuff is the ancient crust of the moon. It's a type of rock that we call anorthosite. We call that the lunar highlands. And this is actually where we're planning to send humans back to, is near the South Pole onto the white stuff to explore. You can also see the moon is covered in craters. This is a fresher crater down here. This one's called Tycho, and you can see those rays that I pointed out on Mercury. So a lot of really similar features from one body to the other. The reason why there's two images of the moon here is because I wanted to give you two perspectives. On the left side, this is actually an image of the moon taken by an astronaut in the Apollo capsule, Apollo 11, looking back at the moon on its way home. And you might see that it's different perspective than the picture on the right. On the right, this is actually a compilation of images that were taken from the Lunar Reconnaissance Orbiter, which is a satellite in orbit around the moon. That's why everything is so crisp and detailed. This is what you would see of the moon when you're looking up in the night sky, because we always see the same face of the moon. The view from the Apollo astronaut, he's actually seeing part of the far side of the moon. And this is something that you will never see from the surface of the Earth, because you have to go around the other side. So just thought I'd give you a couple of different perspectives. And that same spacecraft that took those detailed images took this image here as it was orbiting the moon, just to give you an idea of what the surface really looks like. But there are no flat plain deserts definitely in the lunar highlands. So this is an example of lunar highlands. And then the moon is covered by regolith. It's all this after billions of years of being bombarded by space rocks. It's really mashed up the surface, and so we call this regolith, is the gravelly, boulder-rich stuff that covers most of the moon. So that's what it looks like. This picture on the right was taken by an Apollo astronaut on the surface. And then moving on to Mars, this is our other nearest neighbor on the other side. And Mars, although it's a lot smaller than Earth, it is actually the most like us. It has a very similar past. It used to have water on its surface. It used to have a thicker atmosphere, but that changed some time ago. And we're not exactly sure why. We have some guesses, but we can talk about it in the question period if you like. But Mars, this is two different views. So the left side is taken from Viking spacecraft. Again, it's several images that were patched together to give you the whole global view. The coolest part about this image is it shows you a lot of the different features on the surface of Mars. So even though Mars is one of the smallest planets, it has some of the biggest features in the solar system. It has the largest of volcanoes. That's these volcanoes here. The largest is Olympus Mons, which I have in the next slide. It has the largest valley network. So this is called Valles Marineris. It's far bigger than the Grand Canyon. It's as wide as the United States is the whole country. It's huge and very, very deep. On the right side, this is an image that was taken by the Hubble Space Telescope. And you can see Mars actually has seasons. It's like Earth in that way as well. And it has ice caps in the North and South Pole, which change throughout the year and throughout the seasons. And you can see that there's different terrains on Mars. And sometimes Mars has global dust storms. And then if you took a picture then, all you would see was a single color of, like an orangey haze over the entire planet. It's pretty spectacular to see. Mars's atmosphere is similar to Venus's in that it has mostly carbon dioxide gas, but it's much, much thinner. And it does have, there is weather on Mars. The wind does blow. They have little dust devils. Really, really cool features on Mars. A lot of similarities to Earth, and it has two tiny little moons. I'm going to go in a little closer. There are currently 8 orbiters working that are around Mars right now, taking pictures from orbit. This is just a couple of examples. This is Olympus Mons, that large volcano. These are gullies. This is an example of ancient river valley networks, carved channels that's how we know, one of the reasons, one of the many that we know that water used to be on the surface of Mars. There are ancient river channels, ancient canyons, things like that. And they also have, their share of rocky deserts and impact craters. We also have 3 working rovers on the surface of the planet. We've sent 6 in the past, but 3 are still operating. 2 of which were landed just last year, Perseverance and the Zhurong from China. And this is Perseverance. It took a selfie. It took a picture of itself and then sort of deleted its arm out of part of the picture so it would come out nice and crisp. And this is his buddy, Ingenuity. Ingenuity is a tiny little helicopter, so we've actually flown succeeded in powered flight on another planet. So we've flown this tiny little helicopter on Mars. It's flown over 20 times now. It works really, really well. It has to be extremely light because the atmosphere on Mars is very thin, but it still works. And Perseverance is continuing to explore. It's exploring what's called the Jezero crater. It's an impact crater, but used to be a giant lake. It used to be filled with water. Now that water's gone, and there was a river pouring into it that dumped out all this sediment, and Perseverance is just approaching this pile of sediment that we call the delta deposits, and it's going to look for signs of life. So pretty cool. Maybe there's life on Mars. We'll see. I thought this is another cool image to show you from Mars. This is from the Curiosity rover, another one of NASA's rovers on Mars, but Canada has plays a big role in the science teams on both of these rover teams. Anyway, this is a sunset on Mars. This is a sunset in 2015 in April, through sort of a hazy evening. But this always kind of gives me a little tingly feeling looking at a sunset off of another planet. So I'm going to move on to asteroids. This is a kind of a funny diagram. So just to show you where asteroids tend to hang out. So the asteroid belt, the main asteroid belt, is between the orbits of Mars and Jupiter. There are thousands of asteroids, except for they're not bunched together like this image is showing. They're actually quite far apart from one another. It's a lot of space. And then they also find what we call Trojan asteroids, which follow and lead Jupiter around its orbit. We've actually sent spacecraft to many asteroids, or they've snapped a few photos on their way by, on their way to other bigger destinations. So this is just some examples, but you can see that they come in a wide variety of shapes, sizes, and composition. And these are really the leftovers, the remnants of the formation of our solar system. And so there's a lot we can learn by looking at asteroids and comets. This is the largest asteroid. It's called Ceres in the asteroid belt. So large, in fact, that we call it a dwarf planet, but it has no moons or no rings and no atmosphere. And it was visited by the Dawn spacecraft. And if you're wondering what that little dot in the center of this crater is, this white thing, it's actually a salt deposit, as the Dawn spacecraft discovered. And then this last asteroid I'm going to show you is Bennu. Bennu is very special. It's a cool animation. This is sort of the most detailed data that we have of an asteroid. The OSIRIS-REx mission went and imaged this, and on board it used an instrument called OLA, which is a laser ranging instrument. And it's actually Canada that designed and operated it. And it, using a laser, took pictures and defined the topography, so all the textures of the outside of this asteroid. It orbited it for 2 years and then compiled all of that. Then another instrument, a camera, took pictures. We put one on top of the other, and whammo, we get this beautiful animation of the asteroid Bennu. Bennu is pretty small. It's only about 565 meters wide. But once this image was taken, then they picked a landing spot. They actually went in and did like a grab and go, and they collected a sample of this asteroid. This is what it looks like on the surface to the right. And it's currently on its way back to Earth, a sample of an asteroid, and it's going to arrive next September. So that's pretty exciting. So this one, this is my challenge to you. What are we looking at? What planetary body is this? Does anyone know? You can put it in the chat. I'll give you a couple seconds. Pretty funky looking. I don't see any answers. I'll give you a hint. We're looking at the North Pole of this planet. This is a view that was taken by the Juno spacecraft. And for a long time, we had no idea what this planet's North and South Pole looked like. Nobody? All right, I'll tell you. This is the largest planet in our solar system, covered by these massive cyclone storms, basically from pole to pole. And it has a very, very thick atmosphere of helium and hydrogen. But there's also some ammonia clouds and water clouds. This is Jupiter, you're right, Brandon. But you're probably more used to seeing it look like this. And that's because the poles have this bluish tinge to it because they're much different temperature and there's different gases that are swirling closer to the poles. So yes, it's Jupiter. And for a very long time, until this Juno spacecraft, just recently in the last couple of years, that image I think was just taken a couple of years ago, has really shown us what the rest of Jupiter looks like. And so this is still accurate. You know, if you're looking dead on, Jupiter does look like this. It is more beige, red, white, you know, these streaks of swirling storms and clouds. That's definitely still it looks like, but at the poles, it becomes this sort of, has these bluish hues and these really interesting interactions between these cyclone storms. And so you'll also recognize, you know, the great red dot, it's still going strong. This image to the right, this was taken by the Hubble Space Telescope, and this image is, this you can see by how crisp it is taken by Juno as well. Juno is a spacecraft that's investigating Jupiter and all its moons. And it's come up with some pretty amazing results so far in just the images alone, but it's also learning a lot about Jupiter's atmosphere and things like that. Jupiter spins really fast. Its day only lasts 10 hours, but it takes 12 Earth years for it to orbit the sun. How many moons do you think Jupiter has? I'm only going to give 5 seconds for this because I want to get to all my other slides. So how many moons? 12, 27, 46. Those are good guesses. Jupiter has 79 moons. 79. And that's all that's how many we know of so far, but I bet you there's probably more that we haven't discovered yet, that they're much smaller. But only about 26 of them have names, and those tend to be, 26 of them have names and tend to be the larger ones. There's a lot of really interesting moons. I wish I could just jump and show you all of them, but I'm going to show you 4 of the largest moons. They're called the Galilean moons because Galileo discovered them. And the largest moon in our solar system, bigger than our moon as well, is Ganymede here. And that same Juno spacecraft took some close-up images and flybys of Ganymede. So we have some really beautiful shots of its surface. You can see that they have a fresh crater here too, you know, with those crater rays. And the other 4 are, Ganymede here again, is Europa, Callisto, and Io. Io is the one that's behind me. Io is one of my favorite moons because it's really unique. The whole world is super volcanically active. It is the world that has the most active volcanoes in the solar system. They're constantly erupting, thousands of volcanoes, but they're not mountain volcanoes. They're more like lava lakes. And then when they do erupt, there's these huge plumes, like mushroom clouds of sulfur and vapor that you can see, you know, shooting out against the black of space. It's really, really cool. And it's really unique body, and it orbits really, really close to Jupiter. And it's because that's why it's so warm, is because the gravity kind of plays tug of war with Io, and it keeps getting squished, and the friction on the inside of the moon is what heats it up, and the volcanoes are its way of losing its heat. The other 3 moons, the larger moons, are ice balls. They're icy worlds, and all 3 of them are thought to have, beneath kilometers of ice that forms their crust, liquid oceans, like a salty water liquid ocean kilometers beneath the ice of their surface. Europa has even shown that there are some geysers, you know, so it's been spewing out some water vapor from the surface. So we think that there is some activity on the inside, and there's a spacecraft, the Europa Clipper, that's going to visit that in the next couple of years and find out what's going on there. So these are really, really cool. There's several moons in the solar system that we think might have under ice, you know, it's an icy world, but that there's a hidden water ocean beneath the ice. It's going to move on to Saturn. I like these 2 different views. If you look through Hubble or a telescope from the surface of the Earth, Saturn typically looks like this. You can see all of its beautiful rings. It's our 2nd largest planet, and it's the one where the rings are most prominent. But if you turn your view and you look at if you look at the rings from the side, you'll actually see that they are paper thin. They're made up of tiny little particles of rocks and ice, but they are crazy, crazy thin. In front of Saturn here, this is its largest moon, Titan, which I'm also going to show you because it's really funky too. But before I get to that, I wanted to show you this image. This is a really famous image that Carl Sagan likes to point out, the pale blue dot. And so this pale blue dot here, what do you think this is? This is Saturn. This is the night side of Saturn. We're looking underneath the rings out towards, out towards the inner solar system, we'll call it. What do you think that is? Yes, it's Earth. Good guess. That is what Earth looks like from Saturn. That is planet Earth, that tiny little blue dot. All right, so here's Titan. It is a wacky, wacky moon. It's a wacky world. It's the only other body that has liquid lakes on its surface. No joke, lakes, except for it's not water lakes. These lakes are made up of ethane and methane. These are a type of hydrocarbon. The whole surface of Titan is really, really weird composition, very different from most of the other bodies in our solar system. And we actually had the Cassini spacecraft that took those Saturn images, had a little buddy on board called Huygens, and Huygens landed on Titan. He didn't survive very long once he landed, but he did take this picture of the surface. The reason why Titan looks like this greenish hue is because, like Venus, it has a very, very thick atmosphere, and so we can't see through it with a regular camera. So you still have to use radar to map Titan as well for the same reason. And we're sending a spacecraft there called Dragonfly, which is a quadcopter. So it's basically a drone that we're going to send to fly on Titan in the next couple of years too. So that's another really exciting thing to keep your eye on. It does look a little bit like a plastic ball, doesn't it? And then another Saturn's moon is Enceladus. It is another cold ocean world that has geysers erupting from its south pole. So they're like volcanic eruptions. It's an ice volcano, but instead of erupting rock and lava, it erupts ice and vapor, volatile vapors. I'm going to move along a little bit quicker just because I don't want to take up your question period of time. So this is Uranus. So we only have 2 planets left, Uranus and Neptune. And so Uranus and Neptune, they're cold, stormy gas giants. But the only information that we have from them are from telescopes and one spacecraft, which was Voyager 2, which visited them a long time ago. They were launched in the late 70s, and they got to Uranus and Neptune in the 80s. I think I was, maybe 4 or 5 years old when these images were collected. So this is a Voyager 2 image of Uranus. And this is an image taken from the Keck Observatory, which is a telescope that's on the surface of the Earth. It's actually in Hawaii. So Uranus has rings, but they're very, very faint, so you rarely see them. There's only a couple. And the weird thing about Uranus is that it orbits, it rotates on its side. It's completely tilted over. Uranus has 27 moons, and there's just like a couple of the larger ones down there, but I won't go too much into detail. And then Neptune is our last main planet. It's dark and cold, same thing. These are the only, very, very limited images that we have because we haven't sent spacecraft out there for a while. And this is its largest moon, Triton, which is also possibly an icy ocean world. And Neptune is known, it's a little bit bluer. It's still the same composition as the other gas giants, but it's a little bit bluer because there's a little bit more methane in the top of its clouds. And it also has, the large storms. And the one funky thing about Neptune is it has wind speeds that go faster than the speed of sound. It has the fastest winds in the whole solar system. So it's pretty crazy from that point of view. I also wanted to show you Pluto and Sharon. Pluto is a dwarf planet, used to be a planet when I was young. So, always has a special place in my heart. And its large moon, Sharon, it actually has 4 other small moons, but they're much, much smaller. But the New Horizons spacecraft, which arrived at Pluto in 2015, or did flybys of Pluto in 2015, really opened up our eyes because Pluto used to be, a fuzzy dot in our information. And now we know that it has these beautiful glaciers, it's different color, it has mountain chains, it has craters, it's round. And the same thing with its moon, Sharon. There's a lot of different features. There's a lot going on in these rocky bodies that we never knew about. So really funky. This is just an image to show you that beyond the orbits of Pluto and Neptune, there are tons of rocky bodies out there. That's where sort of the comets live, and then they come in on very elliptical orbits around the sun, and then they go back out. And so I'm just going to very briefly show you one comet. I think that's the end. So comets, of course, are made up of rock, ice, and snow, and gas, and dust. And that stuff kind of, when they come in closer to the sun, they end up having these tails. One's an ionic tail, and one's a gas tail, or a dust tail. So one tail goes always in the opposite direction of the sun, the other one always in the opposite direction of the trajectory it's taking, the way that it's moving. And we have actually visited a comet. This is, I think we visited a couple, but this is my favorite. This is the comet 67P. It has a longer name, but I'm not going to try and pronounce it. But I always think this looks like a rubber ducky. And so this rubber ducky comet, we had the Rosetta spacecraft orbited it for a couple of years, and then a Philae lander landed on it. This is its view, but unfortunately the lander didn't work super well. It because the comet's so small, it's about 2 kilometers wide, it doesn't have very strong gravity, and so when it tried to land, the spacecraft bounced, and it had these anchoring harpoons that were supposed to sort of jet out and hang on, and they failed, and so it bounced uncontrollably, and we didn't get too much data from it, but we did get some. And this is what it looks like on the surface of a comet. It looks like a snowstorm, but it's actually just, there are ice particles, but they're kind of going in every which way. So it's not actually, there's no clouds. All right, and then, yeah, so, you know, if we back up for a minute and we come out of our solar system is part of the Milky Way Galaxy, which is a spiral galaxy, which looks something like this. We're actually on one of the outer arms of the Milky Way Galaxy. And if you were to look just like our solar system, if you look from the side, it's all in one plane, so is the galaxy. And so when you look up the sky and you see that really high concentration of stars on a really clear night, that's you looking towards the inside, towards the inner part of our galaxy. And with that, I'm just going to say thanks, and I really look forward to chatting with you for the next few minutes.
Hey everybody, let's give Cass a hand. Thank you so much. We have lots and lots of questions, really cool questions, but I'm gonna pick maybe my favorite to start with. Well, how come other stars look so small if the sun is so big and it's also a star?
That's a really great question. You know what? Stars come in all shapes and sizes, and our star is sort of a medium to small sized star. But the other stars look so small because they are really, really far away, right? Even on the surface of the Earth, if you're looking, you know, at a person, and you see you're in a plane and you're looking down at the surface of the Earth, you're looking out the window of the plane and you see someone standing there, they look like ants, right? It's just because they're really, really far away. But in fact, some of the stars that you see in the sky at night, they are far bigger than our sun. You know, many, many times, in fact, thousands of times bigger than the sun. Because our sun's pretty small on the grand scheme of stars.
Someone from Ireland asks, what is inside our moon? What sort of core does it have?
What sort of core? Well, the moon was actually formed from an impact with the Earth. And so the moon has a very similar composition of the Earth, but it's mostly made up of what the Earth's crust is made up of. So it's a lot lighter. And so the inside of the moon does have a core. It does have, you know, an iron nickel core, but it's much, much smaller than the Earth's core. And then it's, how do I explain this without using big words? And then its mantle, sort of the middle section of the moon, is very similar to ours too. And then the surface, the crust of the moon is made up of something similar to what our crust is made up of. So it's got a much smaller core. It has a lot less heavy elements, you know, a lot less iron and nickel and the heavy metals. But otherwise, it's really similar to the composition of our crust.
Why is Pluto a dwarf planet? What makes a dwarf planet a dwarf planet?
it has only to do with an organization that decides on how things are named. And that organization at some point in time decided that planets had to be at least, this big. Can't remember the actual figure, but they decided that the cutoff for planet was a certain size, and Pluto was below that size, and so it got demoted. But Pluto itself has not changed from before and after they named it. We didn't learn anything new. They didn't change the name because of anything we learned about Pluto. It was literally just an organization that the semantics is just just because they set a limit to how big a planet could be. Pluto is no less awesome.
Someone said it looked like chocolate in the comments.
It does, kind of white chocolate, right?
Yeah.
Poor Pluto.
Someone asked a question. I'm not entirely sure I understand it, but what is the effect on our solar system if the universe is expanding so quickly? Is that true? Is the universe expanding really quickly?
It is. The universe is expanding pretty much to infinity. The effects, from our perspective, we won't notice much, especially not in our lifetimes, in a single human's lifetime. There's not a whole lot of difference that we can see. But eventually there'll be big changes. Even solar systems, the expansion of our universe will not affect our solar system on a small time scale. And even our solar system, it's on its own life cycle, right? So our star is about middle-aged. It's stars like our star, they live to about 10 billion years, and our star's about 4.5 billion years. And so in about another 5.5 billion years, our star will explode and our solar system will be no more. And then, billions of years later, a new star will form and new planets will form. So.
Someone wants to know if you could tell them what a good telescope to buy would be, like for a classroom. Do you happen to know? Or maybe where they could look?
I can get back to them. I don't have one on the top of, on the tip of my tongue.
Well, I can tell folks here in Cambridge, you can actually borrow telescopes from Idea Exchange. So those of you who are local, you can borrow a telescope and use it in your classroom or your home.
I would reach out to the Royal Astronomical Society too. They're a really great resource, and so they'll help you, not only direct you to where to buy things, but you can also they'll take you out and help look at the stars with you. Bring out they organize a bunch of star watching events, so you can Google them. They have chapters all over the place.
So we just have one more question. I'm not sure if it's a big question or not, but I'm going to throw it out at you anyway. How come the planets are so different from each other?
That's a really great question. In their early formation, one of the main things that made them different was their distance from the sun. So the planets that much heavier materials, they stayed closer to the sun. They didn't get pushed out as far. Whereas the more gaseous planets, right? The volatile elements, they got pushed further out where it's cold. There's something called the snow line. And so there's this main division between the planets that are closer, they're much heavier elements, and the planets that are farther away, they're much lighter elements, and they are solid further away from the sun because it's colder. So that's one thing that divides them. The rest of them is each planet sort of evolved on its own through the years, and different things happened to them through the years. Like Venus got really hot because it somehow kept its atmosphere for so long that it now has this runaway greenhouse effect. Whereas Mars's atmosphere got blown away, and so now Mars is cold and dry and lost all its water. So each one just evolved very differently, but they were very similar early on, outside of the early spread of the composition. At least we think.
Yeah, I guess there's no one old enough to ask, right?
Exactly.
Well, thank you very, very much. I really enjoyed that, and I think everybody else did too. Before we go, let's everybody give another round of applause to Dr. Cass Marion and the Aviation Space Museum. Thank you so much. And we hope to have you back again some other time.
Sounds good. Thanks, Brandon.
Hey, everybody. Have a good day.